Hello, everybody. Thank you for coming today. Today, we're going to be talking about AI and machine learning, and specifically AutoML. So my name is Nico Rode. I'm a senior data scientist here at TIBCO. I was actually on the engineering team for AutoML. But AutoML is definitely a trendy buzzword at the moment. You know, it's a word that promises quite a bit. Like the whole idea of automatically creating a machine learning application without a deep understanding of statistics or programming is honestly a little seductive, right? It's a pretty cool concept. But before we dive into that, I think it's always good to look at the broader landscape of statistics and AI to help give us some perspective on sort of where we're at and the importance of AutoML in today's environment. So this is a little bit about us. Disclaimer, you guys are very fast readers. So we'll start with an overview of AI, and then we'll talk a little bit more about AutoML, and then we'll jump into a demo at the end. But I think the fact that we're actually even talking about AutoML or automated machine learning is pretty remarkable, right? Considering that just a few decades ago, in the 50s, we really saw the birth or the genesis of the AI and machine learning, right? This is sort of my timeline of events. And the field has lived through quite a bit, right? In the 70s, you had the AI winter. Statistics and machine learning really sort of found their way out of academics and into the world of software. We saw the rise of companies like SAS or SPSS, and it was really starting to grow after that AI winter, and especially in the 80s, right? One of the big developments in the 80s was databases, and that fueled sort of a mini explosion of AI into the 90s. And this time in the 90s, it wasn't just academics, right? Although there were huge advancements with things like the random forest model, ensemble models, support vector machines, but there was a huge shift from AI and machine learning sort of being into the public eye. The big event in the 90s, 1997, was Deep Blue beating Garry Kasparov in a chess tournament. And that was something that was huge at the time, right? It sort of shoved AI into the foreground and almost into pop culture, really. And then you get to sort of the 2000s, and this is a little more familiar for me, at least. You have the big Silicon Valley companies starting to leverage these new technologies and techniques, right? Advancements in parallel computing, storage was cheaper than ever. You have these big, diverse data sets. And all of a sudden, with AI and machine learning, you're able to do some pretty interesting things. And the marquee example here is the Netflix challenge, $1 Million Challenge. Then 2010s and sort of 2020s, we've come full circle, right? What is sort of the trend now is taking old algorithms, right? Things like neural networks that were sort of come up with in the 50s and enhancing them and actually being able to use them to their full potential because of these different advancements. And again, being deep learning now coming out of neural networks. So the next step sort of now is the idea of automatically creating these AI applications, right? The ability to empower a citizen data scientist and allow them to leverage the same techniques that somebody with programming or statistical experience uses, but now it's allowing a citizen data scientist to do the same. So what does it actually look like, right? What actually is automated machine learning? And I think it's something that can take a few different forms, but at TIBCO, we have a couple of distinct characteristics that we think make up the definition of automated machine learning. The first one, and probably the most important, is automatically preparing and cleaning your data, right? It's sort of the consensus right now is machine learning is 80% data cleansing, right? If you have raw data, it's probably dirty, it's probably sort of mangled, and you need to spend most of your time prepping that data to make sure that you can use it in an actual model. So an AutoML solution should be able to handle this. The second characteristic is, okay, once you've cleaned your data, automatically generate new features from that data. And generate features using sort of agreed upon or industry standard data science techniques. And this is also something that AutoML should be able to do. The third thing is, okay, you've cleaned your data, you've generated all these new variables that you might want to use in your model, but which ones do you actually want to use, right? Which variables, which columns, which data points are actually important for your prediction? So AutoML should be able to intelligently select these variables. The fourth thing is probably the face, or what's talked about most when it comes to AutoML, and that's actually creating a litany of different models. Automatically, not only creating different types of models like a random forest or SVM or boosted tree model, but actually create different submodels too, right, with different parameters. So being able to generate many different models and compare all those models with each other and against each other to find the best fit, so to say. So at the end of this, right, you've chosen the best model, or AutoML has chosen the best model with the best features that it's selected, with new features that it's generated, with data that it's cleaned. And these are sort of the four major characteristics of an AutoML solution, being able to do this automatically without writing any code. And once you're able to do this, then you sort of see the benefits of AutoML. So the three key things here are efficiency, speed, and ease of use. Right? If your AutoML solution is able to do all of that, then all of a sudden you see these rapid sort of starts to these machine learning projects. Right? The ability to take a raw data set, press a button, and generate these whole workflows or pipelines of cleaning and engineering new features and selecting and modeling. That's a huge benefit to have. I think one counterpoint to this is I don't think many people in the industry will say that AutoML will automatically create the best model and you can press a button and take that model and throw it into production. I think that's a little unrealistic, but the benefits are still there of, even if your model isn't perfect, an AutoML solution should be able to still provide you with a data cleaning pipeline, new engineered features, and then maybe selected features too. And if we go back to this last slide, our goals at TIBCO was really to make AutoML transparent. So the idea of, if you use AutoML, it generates all of this for you. You can choose and pick and digest and splice whatever portion of AutoML you want to use. And we'll actually see that today in a demo. And we'll see that in TIBCO Data Science. TIBCO Data Science is our visual analytics tool. So it's a low code, no code environment where you drag and drop data sets onto a canvas, and then you can drag and drop operators and connect your data to those. So an operator might be something as simple as a row filter, or maybe you could join two data sets together, or you can even drag and drop fully fledged models onto the canvas without writing any code. And you can execute these workflows, and it essentially translates these visual operators into Spark code and runs in the backend. Additionally, you don't have to just do these sort of simple row filters or joins. If you have some sort of R script or Python script where you do some niche transformation, or you create some boutique model, you can take that and inject it into TIBCO Data Science inside of a workflow. And you can join these sort of standard operators and this custom Python code that you want to create, or that you want to use or leverage. But we'll go ahead and jump into it right now. So TIBCO Data Science is a cloud-based platform. So you can see I've logged in here through Google Chrome. And this is what you see when you first get in here. I'm not going to spend too much time going over the features, but we can see some recent work that I've been doing for AutoML. We can see other workspaces or projects that people have worked on. I'm going to navigate to the AutoML demo. And again, you can see the work that I've done just prepping for this meeting. And we can see the project members that are involved. But what we really want to look at is the work files. This is sort of the heart and soul of TIBCO Data Science, and where we get to see AutoML in action. So these are all of the different files that AutoML has created for us, and we'll get to explore some of these. But first, let's go into the main flow and sort of see what we're looking at or see what we're dealing with. So we have a data set here of wine reviews. We have information on each row is a different wine, and we have information on where that wine came from, what winery, what variety, and then we have a grade for it, or points. And so what we've done is we've created a Boolean variable of quality, meaning if a wine got rated at 90 or above, we consider that a good wine. And if it's not good, if it's not over 90, then it's a bad wine. And what we want to do is we want to tell AutoML, okay, this is our data set with almost 70,000 rows, some regular sort of categorical columns and some unstructured text columns. We want AutoML to take all of this and come out with the best model for us. So really all it is as simple as looking for AutoML, dragging and dropping it onto the canvas, and setting a dependent column. So we have some login information here. We set the dependent column to quality of the wine, good or bad. And then we let AutoML sort of do the rest. You can tweak it a little bit of saying, how big do we want, or how complex do we want our models to be? This is sort of a speed versus accuracy trade-off. And then what text columns are we dealing with? But once you set that up, you run AutoML, and I have already done this. So this is sort of the output or the end result of AutoML. And we can see some metadata around our dependent column, which is quality. But what we really want to look at is our model leaderboard. So these are all of the different models that the orchestrator or AutoML has created for us. You see there's a bunch of different models here, different types, different feature engineering strategies, and then what we all really care about, which is the accuracy and F1 metrics, just sort of gauging the accuracy of the model. So all of this was done by just pressing a single button of connecting this data up, creating a Boolean variable, hitting run, and it went off and did its thing. But what's really cool about AutoML in TIBCO Data Science is it's all transparent. So we have these end models, right? We clearly have a best model at the top here, but we can go in and we can explore what actually AutoML did. So we can do that by looking at the different workflows that were generated for us. So when you hit run, AutoML uses Team Studio or TIBCO Data Science API and automatically generates whole workflows for you to explore. So we have a data preparation workflow, which we can look at. We have a feature engineering workflow. We have explainability workflows, but we also want to look at the modeling workflow. So if I go to the data preparation workflow, this was automatically generated. It automatically cleans my data, gets rid of null values, re-encodes the target variable. It does a random sampling, train and test split. We get metadata on our information or on our data set. If I exit out of this and I go to the feature engineering workflow, here you can see it also replaces nulls. It filters out columns that might not be relevant to us. It normalizes everything. And then it comes up with different strategies or different ways to encode our data, our categorical data. And then not only does it do these different strategies, but if we go to the modeling workflow, so I'll exit out of this, it creates all of these different models with each of the different feature engineering strategies. So this is what allows us to get so many different models of different ways of encoding, and we get a lot of different possibilities here. And then finally, they're all sort of pitted against each other, and we find the best model here down at the end. And not only that, we can take a look at which variables or which features were the most important in this model. And then once we do all of this, we can take that winning model and we can actually put it into production. We can do batch scoring on it. Here's an automatically generated workflow that allows us to substitute new data in and it does the correct feature engineering strategy and uses the right model with the right hyperparameters. Something that's new since version 1.2 of AutoML is an explainability dashboard. So here we can use TIBCO Spotfire to actually investigate the results of our model. We can look at all the different variables and explore them and look at the correlations between importance and accuracy, or investigate into a particular variable and really dive deep into, okay, what does this actually look like, and why is this important? So this is something new since 1.2 of using explainability on text variables. So that's just a really quick run through of AutoML. There's a lot of depth behind it. And one way that you can get more information on it is by going to our resource page here. So we have TIBCO Labs community, where we have AutoML, but we have all sorts of other cool projects like this going on for you to download. But yeah, I think that's my time. So I'll open it up for any questions, but thank you.
Thank you, Nico. Are there any questions from the audience? Okay, so our first question, how do I get started using AutoML?
For sure, it's a good question, and a convenient one too. It's sort of the answer I just gave, which is if you go to our community site, here I'll click on it. You can see all the different projects we have going on. Project Air is really cool, Project Art. There's also AutoML here. So if you just Google TIBCO Community AutoML, first thing that'll come up is AutoML, and it'll sort of show you how to get started. We have great documentation on it, and it's pretty easy to get started.